right, these are 5.8 notes. So first let's define the absolute maximum. Absolute maximum means it's the highest point on the graph. Okay, just to give you a little visual, that's if our graph starts down and ends down. So like that point might be the absolute maximum because it for sure is the highest point. Absolute minimum is the lowest point on a graph. Again, to give you a visual, this one would have to start up, okay, and end up. Okay, that point would be the visual of the absolute minimum. Okay, and then just you'll hear me say extrema quite a bit. It's just a set of all the absolute maximum or minimum and relative maximum. So everything included, absolute and relative together, is referred to as the extrema. So basically, anytime it changes kind of direction, it has that U shape in it. This is important to know right here. The maximum number of extrema is one less than the degree of the function. Okay, so we have to know how to find the degree of the polynomial, and then the number of extrema, that means absolute max or min or relative max or min, will be one less. Okay, so it says the possible number of extrema for an odd degree polynomial, for example 9 is odd, okay, is an even number, and the possible number of an extrema that has an even degree, like number 2 right here, 18th degree, is an odd number. So what I want you guys to know, example, okay, based off of this, if a polynomial or an equation, right, the polynomial has the 9th degree polynomial, then it has an even number of extrema, we'll say up to 8, because that's where the 9 minus 8. Okay, it doesn't have to have 8, but it can have up to 8. So for example, it could have 2, 4, 6, or 8. So it could have any of those. Okay, but it's got to be even up to 8. So 8 is the maximum number of extrema it could have. And so then if I have an 18th degree polynomial, it has an odd number of extrema up to, and this is where we do 18 minus 1, up to 17. Okay, again, examples. It could have 1, 3, 5, and keep going all the way to a maximum of 18. Okay, so that's the extrema. Just a little more information, I'll just kind of write it up here. If something has, for instance, if it has a 9th degree, so something that has a 9th degree should have 9 roots. Okay, roots are x-intercepts. Okay, those are different than the extrema. So if it's an 18th degree polynomial, then it should have 18 roots. Okay, all right. So moving on. Okay, let's look at number 3. It says consider this graph and then answer the following questions. So this relates to what we did last class. Last class I gave you all the characteristics and we graphed it. Today we're going to take the graph and then we're going to find all the characteristics. So I look at this graph, and really the first thing I want to know, and really these first two deal with the end behavior. Okay, so just like last class, that's what we're going to start with. So if I look at this graph, we started down and finished up. Okay, so what I want to do is I want to remember what my table looked like last time, and here's that table. And something that started down and finished up had a positive a value, and so it's a is asking us what is the a value of this polynomial. Is it positive or negative? Well, in this case, it would be positive. Okay, just because, again, from this table, I know that a positive a value has one that says down and then up, and down and then up, okay? And then it asks for the degree of this function. Is it odd or even? And so, again, I know it's going to be one of these two, so I look at the exponents. Here I have odd exponents, so this is going to be odd. Anytime it starts one place and finishes in the opposite, it's going to be odd. So this is odd, and you know what, I'm going to go ahead and put because I'm just going to say down up. So like the end behavior, down up. And same thing for over here, down up, okay, because of down up. And then it wants to know, can this function be a cubic? So what does it mean to be cubic is what we have to first understand. So a cubic function, remember the parent function of a cubic function is y equals x cubed. So if we take that highest degree right there, then one of two ways I can figure out whether this is a cubic or not. If I know that I have a cubic function, okay, to 3, then that means I should have at least 3 roots, okay, or at most three roots or x-intercepts. This one has 1, 2, 3, 4. So we can say no, and then one reason is too many roots, but we could also answer this based off of, again, this degree right here. If we looked at the extrema, the relative mix or min or maximum. So this minus 1 is 2, so it really should only have 2 extrema. And here we see that we have 1, 2, 3, 4. So we could also say no, too many extrema. Okay, and so that's just based off of the definitions from above. And then I'm going to skip D and do E first. It says determine the number of absolute extrema, okay? So absolute means it's definitely the lowest point. So since this graph goes down forever and it also goes up forever, then none of these points are an absolute maximum or minimum. So they are all relatives, max or min. So for absolute, you can just simply write 0 or none. There is none for this because they finish in opposite directions, this graph. Okay, so then that takes us back to D. Okay, it says give me the relative extrema, so that means that it is all these points. So then we have 1, 2, 3, 4. So we have 4 total relative extrema. Okay, and then F, we're not going to worry about F, so you can just kind of mark through that. All right, number 4 on the back side. Okay, same thing. To figure out these two, I'm going to look at the end behavior. This graph starts down and ends down. Okay, and then that tells me that down, down tells me we're going to have a negative A value. So this is negative, and then I'm just going to put because down, down. Okay, because we knew that end behavior was that. And that says, is the degree of the function even or odd? Well, again, look at my table. It was here. What kind of exponents do we have? Even. Even. And then we can say same thing because down, down. And then can this be a cubic function? Again, for the same reason, cubic function has to have at most 2 extrema or 3 possible roots. So 1, 2, 3, 4. It has too many roots and it has too many extrema. It's got 1, 2, 3, 4, 5 total extrema values. So no, we can say too many roots / extrema. Again, I'm going to do E first, absolute extrema. So here are all the points that are the maximum or minimum values. Since it starts down and finishes down, this point is the absolute max, which is the absolute extrema. So there's 1 point for that. And then number of relative are all the others. So there's 1, 2, 3, 4 relative extrema. Okay? And then again, F We're not doing that. Okay, so we have 4 relative, 1 absolute, and that's how it is. All right, looking at number 5. So now we want a function in standard form. So we first have to take these roots and write them as a factor. Okay, so for a fraction like this, we're simply going to change that to 3x minus 2, okay, because it becomes the opposite. X equals 0 is just simply x, okay, and then x equals negative 4 becomes x plus 4. All right, and then to write it in standard form, so this is factor form, I'm going to multiply out. So I just work 2 at a time. So I cover that up, and I just FOIL out that x. So I do 3x times x, 3x squared. Negative 2 times x, negative 2x. Okay, and then I drop this down, and now I FOIL this. I do 3x squared times x gives me 3x cubed. 3x squared times 4 gives me 12x squared. Negative 2x times x gives me negative 2x squared. Negative 2 times 4 gives me negative 8x. I do need to combine those two middle terms, so my final answer, 3x cubed plus 10x squared minus 8x. For part B, again, I have a 0, x equals 0, so that's just a factor of x. This factor becomes x minus 2i. This one becomes x plus 2i. Okay, with the i's, I like to do those first, so I'm going to do this first and then multiply by x at the end. So I do x times x gives me x squared, x times 2i gives me a 2ix, negative 2i times x gives me negative 2ix, negative 2i times 2i, negative 4i squared. Okay, this is special because these two cancel. I'm left with x squared minus 4 times negative 1. Now, how did I get negative 1? I squared has a value of negative 1. So what I'm left with is x squared plus 4, because negative 4 times negative 1 gives me a positive 4. So that's my answer for that part, and then I still have to drop down that x, and now I distribute this x to both of those. So I do x times x squared, and my final answer is x cubed, and x times 4, 4x. So that's my final answer. And then the last problem, so I have these zeros. I have x equals 6 2 times. Okay, so what that looks like is x minus 6 squared times x, and this is equals negative 5, so that becomes plus 5. And then I can expand this out, right? X minus 6 times x minus 6 times x plus 5. And then I just FOIL 2 at a time. So I'm going to FOIL these two, x times x squared, x times negative 6, negative 6x, negative 6 times x, negative 6x, negative 6 times negative 6, positive 36. Combine those two like terms. X squared minus 12x plus 36. And now I drop down the x plus 5. And now I distribute or FOIL out everything here. X squared times x, x cubed. X squared times 5, 5x squared. Negative 12 times x, negative 12x squared. Negative 12 times 5, negative 60x. 36 times x plus 36x. 36 times 5, I believe, is 180. Okay, and then now I have this is like terms, and that is like terms. So my final answer here, x cubed minus 7x squared minus 24x plus 180.